Hello everyone, welcome back to the channel. Today we are diving into the realm of speed and power, exploring the fastest jet fighters ever built in the world as of 2025. Aircraft have always fascinated humans with their ability to break barriers of speed and maneuverability, pushing the limits of engineering and human ambition. From the early days of supersonic jets to today's extreme hypersonic fighters, the journey has been remarkable. The quest for speed in aviation began in the mid-20th century. The need for interceptors capable of outrunning enemy bombers during the Cold War accelerated technological innovation. One of the earliest milestones was the American F-104 starfighter, often nicknamed the Missile with a man in it. Designed in the late 1950s, it could reach speeds of over 300 km/h. Its sleek design and powerful engine made it a trailblazer in the era of supersonic flight, even though its operational history was a mix of success and controversy. The Soviet Union was not far behind. The MiG-21, an iconic fighter introduced in the late 1950s, became a symbol of speed and agility. While it did not reach the extreme velocities of the F-104, it could still hit supersonic speeds above 200 km/h, making it a formidable opponent in air combat. Its lightweight design, paired with simple but effective avionics, ensured that it became one of the most widely produced and exported fighters in history. Moving into the 1960s and 1970s, the McDonnell Douglas F-4 Phantom Roman II set new standards for speed and versatility. This twin-engine aircraft could exceed Mach 2, equivalent to around 400 km/h, and served multiple roles from air superiority to ground attack. Its massive production numbers and combat record during the Vietnam War cemented its place in aviation history as one of the fastest operational jets of its time. The Soviet MiG-25 Foxbat represented a leap in sheer speed. Designed specifically to counter American high-speed threats like the SR-71 Blackbird, it could reach incredible speeds of up to Mach 2, 83, approximately 3000 km/h. This high-altitude interceptor was built to climb rapidly and strike with precision, though it sacrificed maneuverability for speed. The MiG-25's development showcased the Cold War's obsession with breaking speed records in aviation. In the same era, the SR-71 Blackbird remains unmatched in its class. While primarily a reconnaissance aircraft, its top speed exceeded 500 km/h, making it the fastest manned jet ever built. It employed cutting-edge technology in stealth materials and engine design to maintain speeds above Mach 3 for long distances. Its titanium airframe, specialized fuel, and afterburning engines were revolutionary, influencing fighter design for decades. Although not designed for dogfighting, its speed made it virtually untouchable by any adversary of its time. The 1980s introduced the F-15 Eagle, which combined speed with unmatched maneuverability. While its top speed was around Mach 2.5, it set benchmarks for acceleration, climb rate, and combat readiness. Equipped with advanced avionics and radar systems, the F-15 allowed pilots to engage enemies with unprecedented precision at high speeds. Its various iterations, including the F-15E Strike Eagle, retained speed as a core feature while adding versatility for multi-role missions. The Soviet MiG-31 Foxhound followed, designed as an evolution of the MiG-25. With speeds around Mach 2, 83, and long-range interception capabilities, it remains one of the fastest operational fighters in the world. Its long fuselage, powerful engines, and radar systems allowed it to track and engage multiple targets at extreme ranges. Even decades after its introduction, it continues to serve as a key component of Russian air defense, showcasing how speed remains vital in strategic deterrence. Transitioning to modern times, stealth technology began influencing speed-oriented designs. The F-22 Raptor is an example of combining supersonic cruise capability with stealth and agility. Although its top speed is only a Mach 2.25, it can sustain supersonic speeds without afterburners in a feature known as supercruise. This allows it to intercept threats quickly while conserving fuel and maintaining radar stealth. The F-22 revolutionized the idea that speed alone is not enough. Integrated technology and situational awareness are equally crucial in modern air combat. The Chinese Chengdu J-20 is another example of a modern high-speed fighter. Designed for long-range engagements, it can achieve speeds above Mach 2, potentially approaching 500 km/h. Its stealth features, combined with advanced avionics and sensors, emphasize that the fastest jets today are not just about raw speed. They are platforms that integrate speed, stealth, and strike capability, demonstrating the evolution from simple speed records to complex combat performance. The Sukhoi Su-57 from Russia also reflects modern engineering trends. With a top speed exceeding Mach 2, it combines stealth, supermaneuverability, and advanced avionics. Its engines are designed for both speed and agility, allowing pilots to engage in high-intensity dogfights and perform long-range strikes. The Su-57 represents a blend of traditional Russian design philosophy, emphasizing raw power and speed, with modern requirements for stealth and multi-role functionality. The Indian HAL Tejas, though not in the extreme speed league of MiGs or F-22s, represents a different approach. With speeds approaching Mach 1.8, it focuses on lightweight design, agility, and cost-effective production. Modern fighter development shows that speed must be balanced with operational efficiency, maintenance, and mission flexibility. Nations are no longer chasing top speed records alone. They are seeking versatile fighters capable of dominating multiple roles in modern conflicts. Hypersonic technology is now entering the fighter domain. Although true operational hypersonic jets remain experimental, concepts like the U.S. Air Force's X-59 and Russia's experimental programs aim to achieve speeds beyond Mach 5. These projects are a glimpse into the future of combat aviation, where reaching 300 km/h may become standard rather than exceptional. The integration of hypersonic propulsion, thermal, resistant materials, and advanced avionics will redefine what is considered a fast jet. While discussing speed, acceleration is equally important. The time a jet takes to reach maximum velocity from zero is critical in combat scenarios. Fighters like the F-16 Fighting Falcon, though topping around Mach 2, excel in rapid acceleration, allowing pilots to intercept threats quickly. Short bursts of high speed combined with agility can often be more decisive than a jet's absolute top speed. Modern jet design balances acceleration, maneuverability, and speed, acknowledging that real-world air combat rarely involves sustained maximum velocities. Engine technology plays a crucial role in achieving extreme speeds. Turbojets dominated early supersonic designs, but afterburning turbofans now provide both thrust and efficiency. Variable geometry inlets, advanced cooling, and adaptive nozzles allow modern jets to push beyond Mach 2 without losing engine integrity. Continuous innovation in materials like titanium alloys and carbon composites supports high-speed performance by reducing weight and resisting intense heat generated at extreme velocities. Aerodynamics are another defining factor. Slim fuselages, sharp nose cones, and delta wings help reduce drag and maintain stability at supersonic speeds. Control surfaces must remain effective even when airflow transitions from subsonic to supersonic regimes. Designers use advanced computational fluid dynamics and wind tunnel testing to optimize every curve of a fighter jet for speed. The marriage of aerodynamic efficiency and engine power defines which jets can approach or surpass 300 km/h. Combat experience also informs design. Jets like the F-15, F-22, and Su-57 were not built solely for speed records. They were engineered to dominate in real combat scenarios. This means speed must be matched with radar capability, missile integration, electronic warfare systems, and pilot survivability. A jet that is fast but blind or unarmed cannot achieve operational effectiveness. Modern fighters therefore combine raw speed with intelligence, communication, and lethality. Speed records are not just for human-piloted jets. Unmanned aerial vehicles and drones are now exploring extreme velocities. Hypersonic drones could potentially exceed 5000 km/h, creating a new dimension in air combat. The integration of AI and autonomous control allows these craft to operate at speeds that exceed human reaction times, pushing the envelope of what speed can mean in modern warfare. Looking back, the evolution from the F-104 starfighter to modern fighters like the F-22, J-20, and Su-57 illustrates a shift in priorities. While the mid-20th century was obsessed with breaking speed barriers, the 21st century emphasizes a balanced approach. Speed is still essential, but it now exists alongside stealth, situational awareness, multi-role capability, and survivability. The fastest jets today are not just machines of velocity, they are integrated platforms designed to win in complex, technology-driven combat environments. In conclusion, the journey from 0 to 30 km/h in fighter jets reflects humanity's relentless pursuit of speed and excellence. Each generation of aircraft has taught engineers and pilots valuable lessons about the interplay of power, aerodynamics, technology, and human capability. As 2025 continues to push the boundaries with hypersonic and next-generation fighters, one thing remains certain: the race for the fastest jet is far from over. From the F-104 to the MiG-31, from the F-22 to experimental hypersonic aircraft, speed continues to captivate our imagination and drive aviation innovation. The fascination with extreme speed is not just about numbers on a dial. It represents the ultimate test of engineering, bravery, and innovation. Modern jets may not always appear in newspapers for breaking speed records, but every time a fighter accelerates past Mach 2, it carries the legacy of decades of human ingenuity and ambition. Understanding these machines allows us to appreciate how far aviation has come and where it is heading in the future. Every jet fighter in history that has reached supersonic and hypersonic speeds has contributed to the knowledge we now take for granted. Whether it is the legendary MiG-25 climbing to intercept at nearly 30 km/h or the F-22 silently supercruising across a battlefield, speed remains the heartbeat of aerial dominance. With emerging technologies, AI-assisted flight, and hypersonic propulsion, the next generation of fighters could redefine the meaning of fast yet again. In essence, the fastest jet fighters ever built are not just marvels of technology, they are symbols of human ambition and the constant drive to push beyond limits. The era of 30 km/h may still seem like the ultimate frontier, but the future promises even more astonishing capabilities. For enthusiasts, engineers, and pilots alike, the fascination with speed will never fade. From classic jets to futuristic prototypes, the story of fast fighters is a testament to what humans can achieve when they dare to push the boundaries of the sky.